All right, so let me give you guys an alternate method for planes. Okay, so the idea here is that we now have a tool called a dot product, right? And so I'm going to use that to make a new equation for a plane. So here's a plane. Here's some point in that plane. I'm going to call that P naught.
Does the point matter?
No, only that it be in the plane. Then off of that point, I'm going to stick a vector that I'm going to say is perpendicular to the plane. This is that normal vector. You guys all with me on that? Okay. Now, over here is going to be some other point in the plane. I'm going to call that P. You guys all with me on this?
P is just a point, it's not a vector or anything. Okay.
P is just a point, P naught's just a point,
Vector M.
and then I've got a vector M. So you're right, the categories are kind of screwed up. I would like to make a vector in here somewhere.
Maybe this is a vector from P naught to P.
Yeah, and I would like this to be a vector in the plane, right? So I would like that to be the vector that goes from P naught to P.
So it's going to be P vector.
So yeah, I'm going to call that the P vector. And the way you're going to make that, right, is you're going to think about P as a vector and subtract thinking about P naught as a vector. You guys all with me on that? Okay, so if I throw some components in here, P naught's going to be X naught, comma, Y naught, comma, Z naught. And P is going to be X, comma, Y, comma, Z. And maybe I'll make the normal vector M1, what the hell, let's make it A, comma, B, comma, C. Okay, and so here I'm just fiddling, right? P should be, what are the components of the P vector?
X, Y, and Z.
Yeah, it should be X, Y, Z, but they're
X minus X naught.
X minus X naught, and Y minus Y naught, and Z minus Z naught. Right, because I don't know where the origin in this picture is. The origin could be over here. Right? And I want this vector to actually live in that plane. I don't want it to just point at this thing. You guys all with me on that? Okay. Now, what should be special about N dotted with P?
Wouldn't it be 0? Or
Yeah, it better be 0, because N's perpendicular to the plane and P's in the plane. You guys all with me? So N dotted with P should be 0. So that would be the vector ABC dotted with this crap, X minus X naught, comma, Y minus Y naught, comma, Z minus Z naught is 0. And if you fill this out a little bit, right, you get A times X minus X naught plus B times Y minus Y naught plus C times V minus Z naught equals 0. Yeah, and if you fiddle with this a little more, right, you get AX plus BY plus CZ plus some frickin' number equals 0. Right? And so you can read the normal vector off. It's right here. That's cool. That is a mega nice trick to know.
So X naught, Y naught, and Z naught was a point.
Yeah, that was some point. So that was, if they ask you to find the equation of a plane through the point, whatever, 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 with normal vector, blah, blah, blah. Right? You plug in the pieces into this. The more useful thing is, if I have a plane and I want to know the normal vector, because I have something about cross products or dot products or something that I know about, A, B, C is easy, easy, easy to pull it out. Make sure everything's on the same side of the equation. Yeah.
what was it that when we created the point P, X, Y, Z, what forces that to be on the plane? Like, couldn't it be like right here where my hand is?
This forces it to be on the plane,
Oh, okay.
right? If that displacement vector
Yeah.
dot producted with the normal vector is 0, that thing's in the plane. If it's not 0, then it's not in the plane. So that's this equation forcing that.
I noticed that at the very end we add the number, but was not anywhere else in the equation prior. Is that just because
yeah.
a plane can be shifted up or down without any effect?
No, that's literally just because I didn't give a shit about writing down all of this. That thing is minus a x naught minus b y naught minus c z naught, right?
And we just don't care about those things.
Yeah, and
That's a value.
like that's a scalar quantity, and usually I don't care about it because what I'm interested in is that perpendicular vector. You're right in that that's kind of a vertical shift, so what else? You guys see that? Like sometimes that thing will matter. Sometimes you'll want to know where this plane is sitting exactly in space. Most of the time, you really only care about what's perpendicular to it. You guys see that?
Okay.
What
Cool.
about vector P naught that you had right there? What is that? Is that
Oh, so that's me thinking about the point x naught, y naught, z naught, right? As a vector.
Is that
the-
like the end positioning would be P naught, or would that be?
Yeah, so that's, I don't know where the origin is in this picture, right? Maybe it's down here. If the origin's down here, then the vector
P naught.
x, y, z, right, would be down here in the, like it's based at 0, 0.
And if the origin was at P naught, then it would be the 0 vector.
Yep.
Yeah. So really what I'm doing is this. I'm thinking about the point P as a vector, P naught as a vector, and the point P as a vector. And then I'm just calculating the difference, which is going to give me this thing, regardless of where the origin is in the picture. You guys all see that? Like that vector, oh. I did something nasty, didn't I? Did you guys see notationally I did something really stupid
Yes,
here?
the-
Is that's what
Yeah.
that's what was confusing? So this point P is this one. This vector is that one.
Yeah.
I see why I confused you.
So we could be like
Yeah.
P sub 1 or something.
Yeah, I should have done like, yeah, I should have done P sub, this is the one you want to talk about or something. You guys all cool with that? Sorry about the notation futzing there.
So then
What's up, Kenna?
So how does that end equation tie into the problem?
So this end equation tied into the problem we were just doing because I had some equation of a plane, right? Like 3x plus 2y plus z is 17 or whatever.
Yep.
And the use I made out of this was, so the perpendicular vector to this plane is 3, 2, 1. And I can just read it off as simple as that. I don't have to set equations equal to each other and chase this crap around the universe. I can just pull this vector off of it, which is what I need for place information.
Yeah, I was wondering, you said the notation thing that it should have been a little different. Its P vector is equal to those 2 points. Should those not have vector hats in?
What if I make this one pink, and then the one I'm using is the pink one?
Yep.
So the other two should actually have vector hats. The confusing thing was that I named 2 vectors, right? This vector here and this vector here the same thing. And that was dumb. Because the one I needed was this one that's actually in the plane, not the one that points at the plane. You guys see that? And that's partially confusion because the difference between this point P, right, and this vector that points at it should be serious instead of just like, oh yeah, just toss a hat on it. You guys all,
You end up on the opposite side of the diamond from P naught if you went over P and then negative P naught, or is that?
Oh yeah, and I might have pointed this vector backwards. It doesn't actually matter, it's still in the plane. It'll be a -0 instead of a 0.
Yeah.
Cool.
Oh,
I
so-
really effed that up.
Yeah. 17 at the end is twice the magnitude of P naught, I think.
Yeah, so this would be P naught minus P.